now I'd like to invite our next speaker, Dr. Adrian Blum, who's the market segment head for circular materials business line functional solutions at Evonik. Dr. Adrian Blum holds a doctorate in chemistry and has been with Evonik since 2008. In Evonik, he held various positions within the group, marketing with a focus on agro-custom manufacturing, most recently with one of the business line, specifically focusing on the successful development and expansion of custom manufacturing of the aCA product for an external customer. Since 2020, he has been leading the global market segment, biodiesel at Functional Solutions. With this, I'd like to invite Dr. Adrian Blum. Over to you, sir.
Yeah, thank you. You can hear me?
Yes, sir, we can hear you.
Yeah, I click on the share. However, now I can share. So fine? You can see the
yes,
screen?
Yes, sir, we can see the presentation, yes.
Yeah, wonderful. Yeah, welcome and good afternoon, ladies and gentlemen. As Shivani said, I'm the head of the market segment Circular Materials for Evonik's business line Functional Solution, and I'm speaking from Cologne in Germany. I will talk today about sustainability in plastic business as we see it in Evonik. I have to say, I thank Shivani for this introduction, especially because it was very high level, it showed the complexity, and I liked it very much. So there's a lot of thoughts in common, and I want to show with our presentation what we are actually targeting as a company, as a German company. So next slide, you can see that we have a long tradition in chemicals. We are actually headquartered in a mid-sized city in the western part of Germany, but we are acting truly global, and I have also a lot of Indian colleagues here. So if you are interested by this lecture, feel free to contact to them and or to me. I'm very happy if this is one of the results. So Evonik is organized into 5 units. We have the business unit Specialty Additives, which you will hear a little bit later, as additives are the things which we need for making plastic circular, not only, but will we have important role. We have another business line, business unit that's Nutrition and Care. I will not focus on that. This is animal feed and exclusive synthesis. Then we have Smart Materials, which imaginably contains our activities in non-mass plastic industries. I only mentioned 3D printing plastics, for example. Then we have, as the 4th business line, Performance Materials, which contains our business for high volume chemicals and the respective process platforms. All have a long-standing century-old knowledge behind it, so that's our base for the future. And the last is technology and infrastructure. Our technology infrastructure organization supports the global plant presence. We have global and regional organizations in nearly all functions, and yeah, you can see the key performance numbers on the bottom of the slide. I would highlight here especially the R&D expenses, which will play a prominent role in the future of circularization of plastics. We have to invest in R&D, and we have to spend R&D to make this world actually better and enable what Shivani outlined during her lecture. So with the next slide, I want to give you some example for sustainability. We are already targeting or have targeted already in the past. Tires is a very prominent example where you use silica to have less friction, and you reduce fuel reduction, though you have a high safety tires, and sometimes this is seen as an opposite, but this is actually working. So in plastics, we heard that prolonging lifetime is important. Our aliphatic crosslinkers for use in wind blades, for example, are very important here to make this happen. And if it comes to design for less waste and the single-use plastic problem we have since quite a long time, you can see that this is one of our key subjects we are working on, and I shall share some examples later. But certainly we cannot end with these examples. We have to do more. And we know that we have a circular economy action plan now in Europe. The global societies nowadays acknowledge this problem and work on this growth problem. And the circularity of material has to translate in a lot of action plans and regulations as well. And this plan you see here is one example for this. It starts with the reduction of waste and ends with something which we have to do less and less. This is the disposition of waste. We have initiated our own program based on these European but also global programs, and we have also submitted pledges to the industry what we want to do on this. This is also very important to really do something in the future. So next slide. Hopefully this works. Yeah, it works. You see that the regulators also work on it. It's not only action plans which are done, but also regulations have already taken off in the past and are moving ahead fast in the future. Enforcement of the actions will be certainly a problem. There's quite a different acceptance level in all the regions. We have to change from a linear to a circular system, and there is quite some difference in speed and enforcement in this case. And plastic cycles, they have still to show the possibility to decouple the growth rates we need from the depletion of the limited resources we have on this planet. So drilling it down from the legislators to the brand owners, we see that they have also a problem with decoupling this circle. It doesn't mean necessarily minimization of for example, packaging and maximization of recycling. It's they announce quite a lot of doings in the up to 2030. The recycled content shall rise to 100% in many product lines of these brands. These are demanding goals to reach. In some societies, there are already single products which have reached 100% recycled content, water bottles of Vittel, for example, in Germany. But these are very singular examples. And currently, the industry is in great problems due to the high prices of recycled materials compared to virgin material. And this will stress the supply chain further. And if you see, Shivani also mentioned 2030 as one of the target dates. What shall be done until 2030 is a very ambitious goal already and will stress our supply chains even more. So we need a lot of technologies, defossilization technologies, and we have to invest a lot of R&D. And here I'm in principle back to my second slide, where I said, okay, we invest in R&D, we spend in R&D. What can we do when we want to enable this transition from linear to circular plastics? So the current value chain is a little bit a different picture from what we have seen before. Is from oil to energy recovery. There's quite some important ongoings from waste management, enabling reuse and recycling. Reuse and recycling, we think, that these are the ecologically and economically preferred cycles. However, they need also a lot of work and support by chemical companies, and still, if we have achieved a lot on this, there will be necessary that other cycles have also are tackled, and we support the freedom of technologies, and we have a vast know-how in these technologies, and so we think to enable successful circularization, we should look in all circles of this currently linear process. And you see on the bottom some activities from our company where we try to enable the circularization. I will elaborate a little bit on examples. First, on examples in mechanical recycling, where our additives support the recycling very much. And then I will also look in the chemical recycling, a much discussed area, which we think is complementary, should be used if mechanical recycling is at its end. It's certainly better than landfill and incineration, which are currently the preferred alternatives. So coming to some examples in the mechanical recycling where we work on, you see the process depicted here. You have separation, floating, drying, you have washing. Washing comes before drying typically. Then you have melting and pelletizing, upcycling and compounding. And in each of these steps, we can support with our additives, we can support with our know-how, we can support also with process technology know-how, and are looking for cooperation. Let's see a fast example. You can see here on the right side what can be done with in the washing with an additive. Without additive in the alkaline washing solution, we have far less material solved in the de-inking process. Here, this gives you a better performance, and this is especially also in terms of energy and cost of the whole process. It's a very advantageous use of such additives. It's our Sulfonol brand. Second would be if you have washed it, then typically you have to centrifuge and dry it, and you can see here that typically you'd want to have as less water as possible because you have to dry it afterwards, and which costs energy. And if you use, for example, a Tego brand example, you can reduce the centrifugation, and you can you have less water on the plastic flakes, which is ecologically preferential, as this is in the current analysis, the washing is has quite a dramatic impact on the economy of mechanical recycling. Next example might be not that prominent, but if you have a bad odor, malodor is an environmentally growing concern in recycling, not only at the site of the collectors, but it's also in the products, in the recycling applications. And to reduce malodor is, as we think, a problem of the future with more and more recycled content, and our Tegosorb additives can reduce malodor quite interestingly, as you can see here, near the virgin we can achieve, and so that should be tested if it makes sense in the application, which I will come later to why one should test and why one should cooperate. Last example from the mechanical recycling would be a physical example. If you have recycled plastic, recycled polymer typically has not that good physical parameters. If you add, for example, a system which like Tego XP, you can have a much better weld strength. The picture on the left actually looks much nicer. However, it's actually not the desired outcome when using this recycled plastic. here you can see that you have a really strongly improved weld strength without looking into detailed numbers. So after mechanical recycling, as I said, there's also technology open field for chemical recycling. Actually, is a huge field. I will not elaborate on feedstock recycling. I will look more in the depolymerization or solvolysis, and especially on plastic like polyesters, polyamides, polyurethanes, polycarbonates, where typically you try to achieve monomer recycling or oligomer recycling. And here in this area, we have some examples prepared for today where we are acting on it. So typically mattress usage in Europe is quite substantially, and also the waste from mattresses is very substantial volume per year. Customers have high performance expectations, and also they want to have low carbon dioxide footprint if they buy such a mattress. It's for sleeping. It's very important. So if it comes to waste, we have to find a recycling process, and there are some companies working on this. We are partnering with the value chain participants and are currently in the piloting of such a process to get building blocks out of such a recycling process. The building blocks can be used again for pre-polymer formulation, which then is added to the foam manufacturing of mattresses. We can also get building blocks for upcycling activities, which we use in-house. And still, at the end, if you make a new product from recycled polyurethane, you also need additives, as shown before, which enhance the performance of the product for the consumer here in this chain. The second example would be mixed polyester waste. Also here, we know that packaging and fiber expectations are quite high. It's high volume, high performance production of both plastics, both polymers, and still we have a huge waste problem. There are many solvolysis processes technology-wise known. We partner here with technology partners, with chemical partners to find industrial scalable possibilities, not only for monomers, new building blocks for polyesters, but also for upcycling applications, as we use such building blocks also in-house. And again, here our additives will enable actually in the circular value chain, again, a product which has a high performance as it demanded from the customer. Yeah, this was the last example I wanted to give for mechanical or chemical recycling. And I wanted to address you with the necessity, we think, that's our view, that coming from a linear value chain, you have to also think differently how to work with the value chain partners. Here's an example of a brand, BMW, you work with in a value chain, in a circular value chain, and you have to partner differently. You have to work with everybody. The raw materials coming from different regions have different qualities compared to a linear value chain. And so we need the connection to every value chain partner in every region in the world. And that's why I'm also talking today here in this lecture. And I want to end actually with something which comes from the German football. There's our CEO, Christian Kullmann. He always said the chemical industry can actually make the path to circularized economy, enables it in these new ecosystems. But because it is a sort of Flankengott, you say in German football, and I looked into India's most famous sports, which is cricket. It's actually a position like a slip fielder we take here, and I hope that you can see the importance of the chemical industry, and I invite you to connect with me and my Indian colleagues and make the goal actually the point, or how you ever name it. And I thank you for your patience, and I'm happy to receive your questions in the aftermath. Thank you very much.
Fine. Thank you for that insightful speech, Dr. Adrian Blum. And we'll be taking the questions at the end of the session. So you can just be here while we take the questions at the end. And just a few things I noted during the talk. So one is, you mentioned that your specialties are the solutions that you have helped to reduce the consumption of resources. Definitely a very important factor as we move ahead, because resources scarcity is something which everyone has been discussing. So there's a very important point that you mentioned. Then the other things you mentioned, some pulls for driving circular economy. One is the regulation as a driver, and the other thing I noticed was consumers pull. Like many FMCG and retailers have already announced their plans in working towards circular economy. So definitely it falls back on producers or solution providers like you to work with them and come up with solutions that address their goals as well. And high cost of recycled materials, definitely as an industry, or maybe as an what do you say a consumer side, we can definitely look at reducing the cost of recycled materials, maybe moving ahead in the future. And then one of the trends that you pointed out was recycling of mattresses. I did notice that a lot of work is happening in this area. So it does seem to be a concern. Maybe in the future, moving ahead, it will be a concern across the globe also. We get to see that in the future. Fine. Great. Thank you so much, sir. It was very insightful for us.